Good day viewers, here welcome back to my YouTube channel. Please, if today is the first day of visiting this channel, please subscribe and turn on the notification bell so that you'll be notified anytime we upload new video. Today we're having this problem that x plus 1 over x is equal to 1. Then x raised to 2023 minus 1 over x raised to 2023 equals that. Actually, this question looks very silly. One of my friends online was asking me if this can be solved without calculators. My reply was yes, this can be done in a very simple way. Now let's talk about how to solve this problem here. Now we have the equation x plus 1 over x is equal to 1. Okay. Now multiplying both sides of this equation by x, so we have x open brackets x plus 1 over x is equal to x times 1. Okay, here we have to open up these brackets, so we have x times x here, x squared plus x times 1 over x is get cancelled, so remaining 1 equals x times 1 is x. So this x crossing over this side, the sign changes, so we have x squared minus x plus 1 is equal to 0. Now we're going to find the value of x to the power of 3. Now if you try manipulating this equation by multiplying both sides of this equation by x plus 1, so let's see what we have. X plus 1 open brackets x squared minus x plus 1 is equal to, remember that x plus 1 times 0, we are left with 0. Okay, now expanding this, so we have here x cubed plus 1 is equal to 0, and from here we have x cubed is equal to negative 1. Okay, now the problem here is to find the value of x to the power 2023 minus 1 over x to the power 2023. How can we do this? Okay, let's think of rewriting this x raised to 2023 as x times x raised to 2022, then minus 1 over x times x raised to 2022. Now we have the value of x cubed here to be negative 1. Now our question is, 2023, is it a multiple of 3? The answer to the question is yes, since we know that 674 times 3 will give us 2022, and 674 is an even number. So in this equation we can raise both sides to the power of 674, then is equal to negative 1 raised to 674. Now with this, 3 times 674 here, so we're getting x raised to 2022, which is equal to negative 1 to the power of an even number is 1. Okay, so we have got that x raised to 2022 is equal to 1. So we're going to make a substitution here. So instead of writing x raised to 2022, we write it as 1, and here x raised to 22, we write it as 1. So we have x times 1 minus 1 all over x times 1, and this simplifies what? X minus 1 all over x. So we can say that in the above equation, the value of x raised to 2023 minus 1 all over x raised to 2023 is the same as finding the value of x minus 1 over x. Okay, so we can say that this question, we have broken it down to a very basic way. So now what are we going to do now to find the value of x minus 1 over x? And once we find the value of x minus 1 over x, we have actually find the value of x raised to 2023 minus 1 over x raised to 2023. Okay, let us write down our equation. X plus 1 over x equals 1. Now we're going to square both sides of this equation, so x plus 1 over x squared is equal to 1 squared. Okay, how do we get this x minus 1 over x when we have here x plus 1 over x? Is this possible? Okay, now let us use the following algebraic identity, that a plus b squared is the same as a minus b squared plus 4ab. Okay, now we have x plus 1 over x squared is equal to 1. Now using this identity here, so we get x minus 1 over x squared, plus 4x times 1 over s and s get cancelled out, so we're left with 4 is equal to 1. Now 4 crossing over the other side, so we get x minus 1 over x squared is equal to negative 3, and taking root of both sides, so taking the square root of both sides here, so we have x minus 1 over x is equal to plus minus root of negative 3, and root of negative 3 is equal to I square root of 3, so we have here plus minus I square root of 3. I is an imaginary unit, which is the square root of negative 1. So we have come to the end of today's video to say that the value of x raised by 2023 minus 1 all over x raised by 2023 is equal to plus or minus I square root of 3, and this is the right answer to the problem. Thank you for viewing, and please make sure you subscribe to my YouTube channel for more interesting videos.